To start off, we must first ask what is a derivative. So the general answer is a derivative is how much an output y is changing in respect to its input x. So we can also say that the input is an argument. To give a better perspective, let's look at something practical, something we already know about. So let's describe displacement as given by function y. Let's not go into what the function is just yet, but build on our understanding. So we all know that the definition of velocity is the change of displacement over the change of time, and that's y dy over dt. Similarly, we also know that the acceleration is the change of velocity over the change of time, and that's y dv over dt. And since the argument hasn't changed from displacement to acceleration, the argument being t, we can describe acceleration as being the second order derivative of displacement. But why is this important? Surely you already have formulas to tell us both. And that's true for most questions, but let's look at some other examples. So let's look at this graph. What is the rate of change of this graph? The gradient. Right, so even if you didn't solve the equation, you surely had some idea how to solve it. But then now what? Suddenly it's not so easy anymore. And why is that? It's because the rate of change here will be different from the rate of change over there. So the only way we can get answer out of this is by having the answer as a function. And that is true using derivatives. So whatever number you put inside the function, 2x, you get the rate of change. So if you input x equals to 3, you'll get 2 times 3 equals to 6, 6 being the rate of change. If you input 0, you'll get 2 times 0 equals to 0. And indeed, if you can see from the vertex of the function, the rate of change is indeed 0. So where did derivatives come about? Derivatives is actually just a gradient formula with limits. So we're actually looking at a rate of change in a very small scale, minuscule scale. So an amount that is almost amounting to 0, but not 0. Because if you have 0 divided by 0, it won't give anything at all. So therefore we need to use limits to find an answer as we approach 0. So if you recall from functions, we know that y is also known as fx. So f, x plus change in x, is your new y, and then fx is your old y. The same goes in the context of x, for x. So if we put the two together, we get the new y minus the old y, divided by the new x minus the old x. And then of course we have to use limits so that we can get an answer close to 0 but not 0.